It is September 12th, 2016. Today's presentation, A Physicist's Thoughts. What do the new Secchi images reveal about the sun simulators? Let's begin. Figure 1 below shows the strange object appearing on the SREM detector images from the stereo ahead spacecraft between 2:09 and 10:09 UTC Coordinated Universal Time on September 6, 2016. The symmetry, and well-defined edges of this object suggests that it is not due to a naturally occurring phenomenon, but that it is a technological device. There appears to be a plasma discharge between the parabolic part of the device and the dark disc-shaped part that would be the focal point of the mirror. So if this was a parabolic mirror or the collector, it would be a solar collector. The device also seems to be rotating from one image to the next. The time interval between each image is 2 hours, so the object is probably rotating quite slowly. Figure 1, Images from the SREM detector on the H1 ahead spacecraft at 2:09, 4:09, 8:09, 10:09, and 12:09 UTC, showing what seems to be a plasma discharge between the part of the device and the shape of a parabolic reflector and what seems to be the collector. Collector, parabolic mirror. Figure 2, solar collector, showing the relative position of the parabolic reflector or mirror and the collector at the focal point of the mirror. Figure 2, let's go back, shows a solar collector, which is used to collect sunlight from the sun and produce heat or generate electricity. The parabolic reflector or mirror reflects all light rays so that they converge towards the focal point of the mirror where the collector is located. Figure 3 shows the object in question again, this time from a Steve Olson video, that reveals some three-dimensional details about this object. Yeah, good job. In this image, we see into the interior, of the parabolic reflector-shaped part of this device. There is also what seems to be a discharge emanating from the parabolic part of the device and hitting the collector. This is indicated in the right image of Figure 3. Figure 3, object seen in Secchi images. Let's proceed. The object in figures 1 and 3 does not, however, seem to be a collecting sunlight, or it doesn't have... Let's try that again, shall we? The object in figures 1 and 3 do not, however, seem to be collecting sunlight like a normal solar collector would. In order to do that, the inside part of the parabolic mirror would have to be pointed towards the sun, and here we see it turned almost completely away from the sun. However, the plasma discharges suggest that it is an energy collector of some type. The form of energy it is collecting is probably ionized particles in the solar wind. Yeah. That's so cool. But since it is turned away from the sun, it is either designed to collect particles from the outside part of the parabolic reflector, or is collecting particles from another object, in which case the disk collector, part of the energy collector, would be pointing towards the object it is collecting energy from. Sensational. Now, since it is probably collecting ionized particles, the energy collector is getting strongly charged to the point that discharges occur between certain points in the parabolic reflector's inner surface at the collector disk. This is illustrated in Figure 4. Plasma discharge, yellow lines, energy absorber, collector disk, Figure 4. Illustration of various components of the energy collector. Now, let us now see where this object is and where it's pointing to. From the HI stars A image on September 6th at 9 minutes UTC, shown below, we can see that Venus, Mars, and Neptune are in view, and we can see their relative positions. Figure 5, Secchi high stars A image on September 6th at 9 minutes, showing the same view as the, so that would be 12:09 actually, but we'll say 9 minutes for military time, right? Gotcha. Showing the same view as the images in figure 1 and also the relative position of Venus, Mars, and Neptune. Why is Neptune so close? Sorry. It just seems odd to me. Okay. Now, with the help of the solar system scope, pardon me, we can align our view to fit the relative positions of the Venus, Mars, and Neptune shown below in figure 5. This is also shown in figure 6. Actually, figure 5 was above, and figure 6 is below. Figure 6 solar system scope image showing the same relative positions of Venus, Mars, and Neptune shown in the high stars A image figure 5. Now, pardon me, since the HI ahead spacecraft follows Earth's orbit, the energy collector is probably between Earth's orbit and Venus, and probably a lot closer to Earth's orbit than Venus. This means that the energy collector is pointing away from Earth and pointing to a position below the ecliptic. What is it pointing to? Is it pointing to one of the stars that have come close enough to the sun to be seen from Earth's surface during daylight hours? Or is the energy collector pointing towards the brown dwarf star, draining the sun of its energy? Very good points. One thing is for show. This object is not acting like a sun simulator at the moment that the images were captured. A sun simulator would be facing towards the Earth. It could be that it has two functions, an energy collection function and a light source generation function, which would then turn it into a sun simulator at appropriate times. Is it perhaps being used to collect energy from an object close to our solar system? Is it an object that is perhaps a little below the ecliptic plane? All of these are possibilities to consider. We do have plenty of evidence, that sun simulators are being used and that there are a few different sun simulator designs. Very well stated. Yeah, what is that little alien-looking guy? Figure 7, object photographed from Earth's surface in the shape of a parabolic reflector, emitting a bright beam of light. Wow. Figure 7 shows another object photographed from the Earth's surface. It has similar features to the energy collector in figures 1 and 3, but it seems to be in emission mode. It seems to be firing plasma, or it may be using plasma to produce a strong light emission. With a strong emission like that, it may simulate the sun or the moon when turned towards Earth. The emission point seems to be a bit closer to the parabolic reflector part of the collection disk that is in the parabolic reflector in the energy collector device. So these are not the same object, but there are enough similarities between the two to suggest that they use the same type of technology, to collect and emit energy. They are likely, therefore, to have an energy collection mode and a sun simulation mode. Therefore, I will call this device from now on an energy collector and sun simulation device, or an ECSS device. Yeah. Rays of energy moving towards collector and lens. Waveguide. Collector and lens, focal point, undeviated part of beam, divergent part of beam. Whoa. You're so smart. Figure 8. Illustration of different components and facets of the energy collector and sun simulation ECSS device shown in figure 7. This device has 4 waveguides. The fact that the beam of energy or light emitted from the ECSS device in figure 7 narrows and then widens suggests that the beam going through a focusing device or a lens. The point where the beam is narrowest is the focal point of the lens. The central part of the beam goes through the lens, undeviated, but parts of the beam outside of the central part are deviated towards the focal point and then diverge outwards after passing the focal point. This is illustrated in figure 8. Figure 9 shows an image that we are supposed to think is the sun from the ISS. Thank you for bringing this back up. But it cannot possibly be the real sun. I agree. The sun cannot possibly show the kind of hexagonal symmetry that we see this light source has or even produce hexagonal lens flares as this device does. Yes. The ECSS device in Sun Simulator operational mode, can go some way in explaining the images of the simulated sun as seen from the ISS, especially the peculiar circular outline of the device. The halo? I don't know. As explained as in the parabolic reflector of the device in figure 7 or the device in figures 1 and 3. The beams of light emanating from the center could be the parts of the beam seen in figure 7 which diverge after going through the focal point. Figure 9. Image of the sun simulator device as photographed from the ISS. The bright source of light is surrounded by a dark circle. Wow. This just gets better and better. Great job. Let's finish this up. The shape we would expect to see from the ECSS device in figure 7 when turned towards us and in sun simulation mode is shown on the left in figure 10. The image on the right in figure 10 is what we see from the ISS sun simulator. That is the halo, isn't it? The halo we keep seeing. The difference between the two is the hexagonal shape of the ISS simulator's light source and the square shape of the sun simulator's ECSS light source from figure 7 and 8. In order to produce the hexagonal shape, we would just need to increase the number of waveguides on the ECSS device, see figure 8 above, from 4 to 6. ECSS light source, ISS sun simulator light source. In conclusion, figure 10, the image on the left is what we would expect to see from in front of the ECSS device that has 4 wavelengths, one for each of the 4 points, thus making the source look square. The image on the left is what we would expect to see if 2 more waveguides are added. Now the light source looks hexagonal in shape like the ISS simulated sun. A physicist's thoughts. Have a great day. Thanks again. Bye.